Good afternoon, class. This is Mr. Morales, and today we're going to begin our study of quadratic functions. First, we have some notes. Now, the first 8 parts of the notes on page 19 here have to do with vocabulary. So what I'm going to do is just kind of quickly read off the explanations and the words that match. But a lot of these will make more sense once we get into that actual graphing and describing in real time. So let's go ahead and just get to the vocabulary really fast. We're asked to fill in the blanks using the vocabulary words given in the word bank. So number 1, the quadratic functions are shaped as a, and the official name for the shape of the graph we're going to be studying, is called a parabola. It's going to be this word right here. It looks like parabola, but it's pronounced parabola. And it makes a U-shaped graph. I'll write that over here in parentheses. U-shaped graph. The highest or lowest points on the parabola is the vertex. You're going to see that when we make this graph, this U shape, it has a point where the graph goes from one direction to back to the other direction, and that point where it turns is the vertex. When the graph intersects the x-axis, we have a couple of names for this. The first one would be called the x-intercept. I'll go ahead and abbreviate that here with x-I-C-P-T. It's also called the zeros, and it's also called the roots. The blank is the lowest part of a parabola. When your graph is a U shape facing upwards, then what you have is a minimum value at the vertex, sometimes just called a min. The vertical line that cuts the parabola in half, that is called your axis of symmetry. And you'll see that when we start practicing working with these graphs one-on-one. Axis of symmetry. All right, our next question is, or statement is, blank is the point where the parabola crosses the y-axis. Well, that would be your y-intercept. Wherever a line hits a y-axis, that's an intercept. So depending on the axis, it's either x or y. In this case, it's the y. Blank is the parent function for all quadratics. So this equation right here is the base function, f of x equals x squared. X squared, more specifically, is the parent function that all these graphs are going to come from. And blank is the highest value on the parabola, the maximum. And we notice we have one word left, and I'm going to go ahead and put that where it does belong. That's also going to be right here. Solutions. We have 4 names for this topic, for the place where you hit the x-axis. X-intercepts, roots, zeros, solutions, all the same thing. And you'll see those in play when we begin our examples down below. So for number 9 and on out, it asks us to identify the key attributes. Attributes are the parts of in this case, the parts of the graph that are most important. So first of all, does this graph have a maximum or a minimum? So when we read a graph from left, we always read it from left to right, and we follow this graph from the left, you see that it goes down. It's right here at 0 in this case, and then it bounces back up again. So in this case, what we have is that lowest point right here, that would be a minimum value. So we have a minimum. Now, do we have any zeros or x-intercepts? Where does our graph touch the x-axis, in other words? So if I follow it going down, right here. Go ahead and finish off erasing what happened. I do want to leave these arrows, however. So we do have a point down here where our graph hits the x-axis. Here's the x-axis. The y's are labeled for us. So we do have a 0 at x equals 0. This is where this curved graph, this parabola, hits the x-axis. Do we have any y-intercepts? Well, yes, at the same exact place. At y equals 0, we have a y-intercept. The graph comes down, hits at 0, 0, and then goes back up. So it's 0 for x and 0 for y. What's our vertex? That's our lowest point in this case, and that would be at the origin also, 0, 0. Our line of symmetry. A line of symmetry is an invisible line that goes through the middle of your parabola, your U-shaped graph, goes through the vertex, and cuts your graph in 2 perfect pieces. In this case, the line is the y-axis. So we have to give this line an equation. This is this line of symmetry for this case for the y-axis is where x equals 0. Every point on this line has a coordinate of 0 for the x value. You have 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, all the way forever. So this x equals 0 is our line of symmetry. Our domain and range. Well, our domain, we notice we have arrow tips here. And this graph really does keep spreading left and right forever. So our domain then would be all real numbers because it goes left and right forever. However, the range, the height, remember this graph, if you read it from left to right, it comes down, hits at 0 on the y-axis, and then goes back up again. So the range, the y values, it comes down, it hits 0, it actually makes contacts with the 0, and then it goes back up, positive infinity, upwards forever, as we can tell by the arrow tips. That's just the basic parent function. We got to practice a lot more to really get the idea of all these attributes. Let's go ahead and go to the next one down. Number 10 is the exact same thing. If you notice now, our parabola is facing downwards. So we would say that this is a negative quadratic. And what happens is when you read it from left to right, you see that it goes up, 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 and then it hits a point right up here. That point is our vertex. And for this graph, that would be our maximum value. That's the highest this graph gets before it goes back down again. Now, do we have any zeros or x-intercepts? And we do, actually. We can see a point right there, and another point right here. These points aren't perfect whole numbers that we would like them to be, so we're going to go ahead and have to estimate. I would say that this point on the left is just a little bit past the halfway mark. So we'll say we have an x-intercept at x equals, let's say, negative 1.75, this square bound. And then we have another x-intercept on the right side over here, right before we hit the 3. That one it's a little closer to 3, so I'll say at x equals 2.8. I should really use approximation signs instead of equal signs. All right, so those are our x-intercepts. Do we have a y-intercept? Is there a point on this graph where our graph makes contact with the y-axis? And if we look, we can see that right here where my cursor is, we do have a point. So this would be our y-intercept. And that value is at positive 2. So our y-intercept is at, we could say it at 0, positive 2, like that. Our vertex, the highest point in this graph, well, it occurs at positive 1, comma 3. So our vertex is at 1, 3. That's the highest point. Our line of symmetry. Well, the good news is once you know your vertex, the line of symmetry goes through the vertex. So if I just drew a line going straight down the middle, I could see I have a line that crosses at x equals positive 1. Because the line crosses at positive 1 on the x-axis. What's the domain? Well, for all of these, the domain is going to be all real numbers because this graph continues to spread forever left and forever to the right. However, the range, well, it has a highest value at positive 3. So it hits the highest value at positive 3 and then goes back down forever into negative infinity. So there is our range. Let's go ahead and continue practicing with our next examples on the back. Number 11. Here we have a different parabola, x squared minus 2x minus 3. That's the equation of the graph. If you read the graph from left to right, we see we have down here a minimum value. It's the lowest part of the graph. If you have the lowest part, then you have minimum. Do we have any zeros or x-intercepts? Well, we have one right there. That would be at x equals negative 1. And then we have another one over here on the right at x equals positive 3. Do we have any y-intercepts? Does this graph make contact with the y-axis anywhere? And it does right here at y equals negative 3. So the coordinates 0, negative 3 is our y-intercept. Do we have a vertex? Well, of course we do. Our vertex is the lowest or highest point. If we have a minimum or a maximum, then you automatically have a vertex. In this case, our vertex is down here at positive 1, comma negative 4. Our A line of symmetry is the line that goes through the vertex and cuts our parabola into two perfect pieces. It hits the x-axis at +1, so our line of symmetry is at x equals 1. We have a domain and range. Well, this graph really does have arrow tips that go on left and right for infinity, so we have a all real numbers situation for our domain. Our range, however, we do have a lowest point. Our lowest point is down here at -4. So -4, our graph makes contact. Our highest point, well, it goes up for infinity. So we have all the way to +infinity. Let's try this again. Let's practice some more. Feel free to pause this video and start number 12 if you'd like, and then compare my answers to yours, and then how you can compare for understanding. Otherwise, if you're still a little insecure, want to work along with me, here we go with number 12. So this graph, if I read it from left to right, I see it rises, it increases until we get to a point up here at the vertex. So we have a maximum value. Do we have any zeros or x-intercepts? Yes, we have two x-intercepts. Remember, x-intercepts are zeros or solutions or roots, as it's also called, are wherever your graph hits the x-axis, the x-line. Well, I'm going to write it a little differently now. We have a 0 at the origin, 0, 0, and we have another 0 at 4, 0. When I write it in coordinate form, this is why they're called zeros, because it's the two places where your y values are equal to 0, in case you didn't pick that up. Do we have a y-intercept? Yes, the y-intercept is also at the origin. So you can have roots, intercepts that are also your y-intercept. It's rare, but it does happen. Do we have a vertex? We sure do. If you have a maximum or a minimum, you automatically have a vertex. In this case, our vertex is at +2, 4. Over 2 up 4, that's the highest part of our graph. Our line of symmetry is the line that goes through the vertex that cuts your graph in half. So this line right here and this line hits the x-axis at +2. So the line of symmetry is at x equals 2. What's our domain and range? Well, this graph should have the arrow tips. So our domain is all real numbers, but we do have a definite range with all these. If they have a max or a minimum, then they have a set range. In this case, we have a highest value of +4. And it actually makes contact at +4, but then goes downward into -infinity as the graph goes on forever. All right, so now we're asked to work a little backwards. Now they're going to give us an equation, and they want us to sketch and identify the key attributes. So here's the equation. X squared plus 6x plus 9. So I'll go ahead and use my graphing calculator to graph this out. X squared plus 6x plus 9. Let's see what kind of graph we're going to get when we do finally get the calculator going to visualize what we have here. So what I'm going to do is I'm going to go ahead and just go right to the, close that up, to the graphing part over on the left. There we go. And the equation is x squared plus, let me see it again, 6x plus 9. 6x plus 9. Enter. There it is. So I can actually do Control T and get a nice little table over here. And I'm going to pick some values that are a little easier to work with from my table. So let's see. It looks like -5,4, -4,1, -3,0. So let me go ahead and transfer this part of the table over here so I can make a graph. Here's my x, here's my y. I have to pick at least about 5 points. So let's see, what's the lowest point? That would be here at -3, 0, right in the middle of what we scroll down to. So I'll pick the points that come after it and the points that come before it. Look at the rest of the values. I have 4, 1, and then it goes back up to 1, 4. All right, so here's my points. So if I graph this, I have at -1, 2, at -3, 0, I have my vertex. 1, 2, 3, 4, 5. At -5, 4 is a point. At -4, 1 is another point. And then it kind of swoops back up again at -2, 1, and -1, 4. So here's a rough sketch graph. Does it have a maximum or a minimum? Well, it scoops down. If I read it from left to right, like you always do, it has a minimum value down at the bottom. It does have a x-intercept at -3 is when it's equal to 0. That's why we call them zeros. It's whenever your x value equals to 0. What's our y-intercept? Well, let me go back to my graph and find it. I don't see it right away. But what I can do is go ahead and try this little function. Let me get rid of the table really quick. Do Control-T. And let's go ahead and do menu, trace. Let's trace our graph. Graph trace. And look, right away, the first thing it does is it goes right to the y-intercept. My y-intercept apparently is at 0,9. That's a nice little trick to have. So whenever you do trace, graph trace, the first point it goes to is a y-intercept. Our vertex is down here at the bottom. That's our lowest point, and that's at -3, 0. Which means our line of symmetry, which cuts the whole parabola in half down the middle, also goes through this point at, in this case, the line of symmetry is going to be at x equals -3. Same value you have here in your vertex. Our domain is all real numbers. This graph goes forever left and right. Our range has a minimum value. It comes down, it hits 0 on the y-axis before it goes back up again. So 0 is the lowest point, and then it goes back up to positive infinity. Remember, with infinities, you don't have an equal sign because you can never reach infinity properly. So now we have some more analyzing graphs. Here we're given two graphs, A and B. And they want us to fill out the following parts. So let's go ahead and let's do this together. I will, however, leave parts 7 and 8 for you to do with your calculator. So number 1, what is the axis of symmetry for graph A? Graph A, the axis of symmetry is a line that cuts the parabola in half that goes through the vertex. Whoops, I'm a little off there. This line right here. You get the equation of the line by finding wherever it hits the x-axis. It hits the x-axis right here at -1, 2. So the axis of symmetry for graph A is that x equals -2. What is the axis of symmetry for graph B? If I had the same concept over here, I draw my line that cuts the parabola in half. Wherever it hits the x-axis at value, in this case, +1, 2, 3, that is my axis of symmetry, the line. What is the vertex for graph A? So let me change up the color a bit. The vertex for graph A is either the highest or lowest point. Right here is my vertex. The coordinates for that are at -1, 2. So that's the first part. The vertex is at -2. And I have to go down 1, 2, 3, 4, -5. So -2, -5 is my vertex for graph A. Is this a maximum or a minimum? If I read the graph from left to right, it goes down. This is a minimum or lowest value. So it's a min. Let's say for shorthand. What is the vertex of graph B? Graph B, the vertex is either the highest or lowest point. In this case, it's right here at +1, 2, 3. So there's my x-coordinate, +3. Let's get the y-coordinate. 1, 2, 3, 4. And since it's the highest point of the graph, and it is a maximum. I'm sorry for making you dizzy, by the way, with the up and down scrolling. It's kind of belongs to the notes. I want to get through it as fast as I can. Identify the domain and range of graph A. All right, so for graph A, we know that the domain is going to be all real numbers. The range, which talks about y, let's see this one. The range, it hits a lowest value at -1, 2, 3, 4, 5 before it goes back up. So it hits a minimum value and makes contact at -5, but then goes back up to positive infinity. How about the domain and range for graph B? Well, the domain, and I keep going back and forth, sorry, is all real numbers. Oops, my pen's delayed. However, the range, R, that's the y value, that is going to be, let's see, it hits the highest value right here at +1, 2, 3, 4. So it hits a highest value of +4 before it goes back down to negative infinity, downwards forever. Now, what I want you to do for your own, for 7 and 8, figure out which equation A, B, C, or D matches graph A on your calculator, and which equation A, B, C, or D for number 8 matches graph B. Let's do that one on your own. Page 22 is blank. Your assignment now is to graph each of these equations for numbers 1, 2, 3, and 4 on page 23. And then using your calculator, do a table and then make your graph. I did one similar to this already for you in this video note, so you can follow that same pattern. If not, feel free to ask me any questions in class when I see you next. All right, thank you, and best of luck with this assignment, guys. Actually, you know what? Before I sign out, let me go ahead and just do one with you anyways, because I don't want to leave you hanging like that. So our last one, our one example here for page 23. We want us to graph x squared plus 10x plus 26. So I'll get my calculator. If I have anything that's already been graphed, I'll dock B and clear it out. Back over here to Scratchpad. And the equation is x squared plus 10x plus 26. Remember to only enter in what comes after the equal sign. X squared plus 10x plus 26. X squared plus 10x plus 26. Press enter, and I don't see my graph. Oh no, something's wrong. Actually, no, nothing's wrong. The matter of fact is the graph is out of the window view. So let's go ahead and go to menu. Let's go ahead and go to zoom, and I'm going to pick zoom fit. This will always make the graph fit no matter where it's at. So here's my big graph right here. What I need now is I need to make the table of values. So I'll go ahead and press Control T for table. Look at all my y values. I'm at 37 right now, and it seems to get higher. It gets higher, 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 higher. I can see that this graph has a lowest point or minimum. So I'm going to go the opposite direction to try to find that lowest point. In other words, the minimum value. So what's the lowest this graph gets? It looks like I have to go back, and it looks like 40, no, 37, 36. So it looks like right here is my lowest value at 0.36. So since 0.36 is my lowest value, I'll put that in my table. I'm going to make 0.36 my vertex. It's the middle point. Now I'm going to pick the points that come before it, so -1 and -2, and the 2 points that come after 0, +1 and +2. And I'll get those values. So for -1 and -2, it's going to be 37 right there. If I go up one more, it's 40. 37 and 40. For +1 and +2, I believe it's going to be the same values again, 37 and 40. Yes, because this thing is reflexive. It's like a mirror image. Now, you're wondering, how do I graph this on my grid here? Well, instead of counting by, I can count on the x-axis by ones, because all my x's are really just going up by ones here. But my y's are pretty big. So I think I'll count these, let's say by, I'm thinking maybe I'll count by, let's try 6's. So this would be 6, 12, 18, 24, 30, 36, 36, 42, 48. I've got my math there a little bit. And I'll get my best graph. So 0, 36, 6, 12, 18, 24, 30, 36. I put my vertex way up here. And then -137, that would just be like right here. +137 would be right there. 240 would be like about, actually a little lower than that, but right here. So I'd only get a piece of the graph, which is fine. My table tells me that I know what I'm doing here. Now my axis of symmetry, your axis of symmetry goes through your lowest point, which is right here at the vertex. And whatever your x value is, that's your axis of symmetry. So in this case, my axis of symmetry is at x equals 0. What's my vertex? My vertex is at 0.36. That's the lowest point. What's my domain? My domain is always all real numbers. My range? Well, it has the lowest value of +36 before it goes back up forever into positive infinity. Now this one had some really big numbers, but I'm looking at the other ones, they should be a lot more manageable. These ones should fit on your calculator a lot better. So use the tricks I did and the keystrokes for number 1. to attempt to do numbers 2, 3, and 4. All right, best of luck now finally, and get to work.